Google just dropped Gemini 3.1 Pro, Anthropic launched Opus and Sonnet 4.6, and OpenAI released GPT 5.3. All are state-of-art models released in the month of February. In my opinion, this is the busiest month in AI history. Everyone on social media is speaking about benchmark numbers and test scores, but what does it mean for us? Why AI researchers are obsessed over Arc AGI 2 and software engineering benchmark tests? So I have designed 5 simple key challenges where I will test Gemini 3.1 Pro versus Anthropic Claude Opus 4.6 and see how they can handle coding, animation, and simple logical planning challenges. Let's first go through Gemini 3.1 Pro release blog and see what Google is claiming about this model. The model was released on February 19, 2026, and right now it is available for developers in preview via Gemini API through Google AI Studio, Gemini CLI, and so on. For enterprises, it is available via Vertex AI, and for consumers like us, it is available through Gemini app and Notebook LM. I will be doing the test on using Gemini app. Let's quickly go through this table where Google has presented how Gemini 3.1 Pro is performing in comparison to other state-of-art models. There are several benchmarks, but I would say most important ones are Arc AGI 2, where models are given some abstract reasoning and is being tested how well they perform. And here you can see Gemini is performing like 77.1%, whereas the closest one is Opus 4.6, which is 68.8%. The other, I would say, benchmark which could be interesting for us is software engineering benchmark, where Gemini 3.1 Pro is around 80.6% and Opus 4.6 is around 80.8%. To be honest, what I get from this table is that Gemini and Opus are performing equally good in several benchmarks. Okay, so in the blog, they are showcasing certain use cases where they are using Gemini 3.1 Pro and showcasing how it is performing in terms of generating some websites, some animations, and creating websites, calling some APIs, and so on. And yeah, that's pretty much it. So this is what the entire blog is all about. And now it's time to jump straight to the challenge. Okay, so let's first understand the challenge. The first challenge is interactive SVG animation. So the idea of this challenge is that we will give a same prompt to Claude 4.6 Opus and Gemini 3.1 Pro and see how well they are going to generate an interactive SVG animation. We want to see how both of the models can understand the instruction, right? So this is exactly the prompt that I'm going to paste to both of the models and try to see how they generate an animation. Okay, so right now you can see in my screen 2 windows, one where we have Claude and the other one where we have Gemini. And I'm going to select in my Gemini app Pro version, which is showing advanced math code with 3.1 Pro, right? And I'm going to also select maybe Canva. So I pasted this prompt and I will copy paste the same prompt on Claude. I'm using Opus 4.6 and the same prompt here. And let's see what they come up with. So Gemini and Claude has come up with their own version of SVG file. Okay, so first let's have a look at what Google has come up with. So to be honest, it looks quite cool, right? You can see that when I'm moving the cursor, the eyes of the elephants are following the cursor. The only criticism that I would say is that I asked the elephant should be standing beside a small pond, but it seems like elephant is standing inside. But overall, the animation looks amazing. When I look at the Claude, let's see how it looks like. Okay, so it is following the guidelines. So elephant is standing beside, but to be honest, if you look side by side, I think Gemini's elephant looks very cute, but overall I think Claude is also following the instructions quite well. But here in terms of visual, I would maybe leaning towards Gemini. So in my opinion, Gemini wins. So let's go to the next round. So in this challenge, what I'm going to test is that to make some kind of a 3D aerospace dashboard kind of thing. This is a very common use case, right? So let's go and check and see how well both of these models can come up with a nice 3D dashboard with just a single prompt. So let's start with a fresh screen. The same setup. We have Gemini on one side, Claude on the other side. So I have pasted this prompt in Gemini, boom, and I would do the same for Claude. And let's wait. And the goal is to see how quickly they can come up with a workable dashboard. And here I think the task is complex. So maybe we will also see whether they can come up with a workable solution with single shot, or do we need to go with multiple turns to make it work? Wow, let's first go through Gemini. And just to let you know, Gemini was way faster than Claude. And this is one shot, and you can see that we already have a really nice 3D animated dashboard with a glowing International Space Station, which is somewhere here, and it is showing latitude, longitude, and the velocity and altitude of International Space Station. And just think of it, like in just one single shot, Gemini has created this dashboard. And look at this, how cool this dashboard is and how smooth it is. And really, I'm very much impressed by Gemini. And let's jump to Claude and see what Claude has come up with. Okay, now let's look at Claude. Definitely one thing that I can see is that it is having some issues connecting to International Space Station API. And yeah, Claude is losing 1 point. So let's try to guide it. I'm just asking Claude again, giving some kind of information that, okay, there is some issues that we have with fetching some data from International Space Station. Wait a couple of minutes and see Claude can come up with some solution. It seems like Claude invested almost like 4 to 5 minutes and still we are facing some issues. It is showing me some latitude, longitude, but I'm not even sure if it is real. Yeah, here it is showing it is simulated. I would say this round Gemini wins. With single shot, it created a workable dashboard, which looks amazing. So now we are 2-0. So Gemini is right now leading, and let's go to the next round, which is algorithm visualization. So the task is very simple. Right now, what I'm going to do is that I'm going to give Claude Opus 4.6 and Gemini 3.1 Pro to do a kind of an animation of linear versus binary search. So the idea is that we want to see a kind of an animated comparison of linear and binary search on sorted array of 16 elements. And the test is that can the AI translate an abstract computer science concept into a timed educational visual? So that is the goal, right? So we will just copy paste the same prompt in both Gemini 3.1 and Claude 4.6 Opus and see how well they can do the visualization of this concept. So let's go. So let's do the same procedure. We have fresh window of Gemini and Claude. Select canvas, paste my prompt, and boom. And do the same thing for Claude Opus 4.6. Paste the prompt and boom. This time Claude was faster, but let's first look at the Gemini and see what it has come up with. So we have a nice visualization where we have a nice heading about linear versus binary search, finding the value 166 in a sorted array of 16 element. And we can start the animation, and you can see that we know about linear search. It is checking one by one until analytics doesn't find 166, and it did 18 comparison as compared to 4 comparison of binary search. So it is giving an information that linear search is of n maximum operations scaled directly with the number of elements. Binary search maximum operations scale with logarithmic of the number of elements. Pretty nice, very nice visual. I like it. Let's jump to Claude. So here the visualization looks pretty cool. Linear versus binary search, sorted array of 16 elements. It is showing that we are trying to do some kind of a worst case analysis. So here the target number is 42 that we are trying to search in an array. And let's start the search. As we expect that it has gone through 10 iterations to really find element 42, whereas in binary search reached much faster. So as you can see, it is also giving us information about what is O of n. In linear search, it has done 11 comparison to reach the result, whereas for binary search, it is logarithmic of n, so only 4 comparisons. Here, basically, we have also given options to change the animations. I really like visualization. Although now if you see both Gemini versus Claude, both are giving us the right visualization, what we have asked for. And so I would say this round is a tie. But if I need to give extra points, I would give it to Claude because of color combination and everything. So current score is 3-1 because last round both model performed quite well. Now, let's go to the next round, which is challenge number 4, to animate neural network mechanics. So the goal is that now we are going to give a prompt where we will ask both the AIs to do the animation to demonstrate the flow of data through a simple feed-forward neural network with 3 layers, input, hidden, and output, and 3 neurons per layer. And the idea is to see if AI can follow this instruction. And the real test here, what I want to see is that how can the AI map mathematical steps to a clear step-by-step graphical flow. Okay, so let's copy paste our prompt. Let me make sure that we have Pro selected in Gemini. I will also select canvas, boom, and do the same thing for Claude. And Opus 4.6 is selected. So let's wait a couple of minutes. So this time in terms of speed, Claude and Gemini were pretty close. Let's look at the output of Gemini first. So what we see is now somehow Gemini also came up with a kind of a dark mode. And here it is giving us an information neural network data flow, step 0 out of 8, network is idle, press play to begin the forward pass. Let's play. And you see that the animation is showing us how data is being transferred from input to a hidden layer to an output layer and so on. Pretty good. Now let's go and look at Claude. So here the visualization looks similar, more or less following the same pattern. Dark mode, same color combination and so on. Press run forward pass to begin. Let's do it. Let's click on run forward pass and we see good visualization happening. And it is also giving information about how the activation function, which is in this case sigmoid, being applied. And then we can also change the speed maybe and see much faster. So basically the animation is quite good. Overall, I would lean towards Claude here because I see consistently Claude is giving a really rich visualization as compared to Gemini. So this round goes to Claude. Okay, so now we are 3-2. And to be honest, now if I'm thinking about the last round where we have done some kind of a visualization about linear versus binary search, I gave a time, although Gemini and Claude giving wide visualization what I'm asking for, but in terms of color combination and everything, Claude was better. So maybe I revert my points and instead of in round 3 where linear versus binary search where I gave Claude and Gemini both 1 point, I would declare single-handedly Claude as a winner. With that, now we are at 2-2, and this is really a tiebreaker round, which is round number 5. Here I'm asking both the models that, hey, imagine you are assigned a task to make a cup of coffee. The real test is we want to see how AI handles unstructured problem solving. The idea is that we really want to see how their thought process is and how they can come up with a solution. So let's copy paste this prompt and see how Claude and Gemini will perform. Okay, so let's make sure that we have Pro versions selected and let's paste the prompt. Boom, do the same thing with Claude. Boom, and let's wait for a couple of minutes and see what they can come up with. Okay, so in terms of speed, there was no significant difference. So let's first look at the results and let's first evaluate Gemini and see how Gemini has performed. We asked for a general framework on how to make a coffee. And the idea is that we can pass it to a robot and so that it can really understand in worldwide how it can go to any kitchen and make a coffee. So let's look at the results. So Gemini has divided this framework into 5 steps. So step 1, map the environment. Makes sense. The first action is to scan the physical space to understand the layout and locate the key zone, locate the water source, identify power sources, find storage areas. This includes cabinet, drawers, and refrigerator. Then once the map, the environment part is done, then go to the next step, which is take inventory. Once the zones are mapped, find the coffee, search storage areas and counter for coffee beans, pre-grounded coffee, instant coffee, or single-use pots. Find the brewing equipment, look for drip, coffee maker, espresso machine, French press, pod machine, simple kettle. Find accessories, locate mug or cup if whole beans were found, search for grinder. If loose grounds were found, search for paper or metal filter. Good. Then determine the method. So here it has given 5 paths. If it is a pod machine, if the system found a pod machine and matching pods, select this path. When to select drip versus filter, when go for manual or press, instant or whole bean, and then execute the process. Follow the selected path. The system performs a physical action to brew a coffee, prepare the water, prepare the coffee, combine, activate the machine or pour the hot water, collect, ensure, and so on. And reset the workspace. The final step is to clean up and return the environment to a neutral state. I want to understand, if we have multiple paths possible, then what Gemini is suggesting to do. So I don't see anything actually here. I was expecting that it might also write something about speed versus user preferences, but I don't see it. Okay, let's look at Claude. I can see Claude has also divided into 6 phases. Phase 0 is mission framing. Before anything physical happens, the agent needs an internal representation of the goal state, a cup of drinkable coffee delivered to the user. In phase 1, environment perception mapping, the agent enters an unfamiliar kitchen and must build a world model, something very similar what we saw in Gemini. Special scan, map the physical layout, countertops, cabinet, drawers, shelves, sink, power outlet, stove, and so on. So now it is in phase 2, constraint resolution. Now the agent maps what it has against what it needs. Hard constraint, which is must have, water, coffee in some form, a method to combine them, a vessel to serve them. Soft constraint, heat source, milk, sugar, or other addition, correct grinding for available device. If a hard constraint fails, say there is no coffee at all, the agent must report the failure rather than hallucinate a solution. I really like how Claude is breaking down a complex problem into a step-by-step, whereas Gemini was very generic. So now let's go to phase 3, method selection planning. Given the discovered inventory, the agent selects the best feasible method. This is where the framework gets interesting because it requires decision policy and not a fixed recipe. The user preferred method overrides default. This is the thing which I was speaking about, and you can see here it is really defining which path to take and when to override. Really nice. Phase 4, execution with monitoring. Each step is executed with sense, act, verify loop. Precondition check, action execution, post-condition verification. And phase 5, attention and learning, where what inventory was available in this kitchen, which method was selected and why, what worked, what failed, user feedback over time. To be honest, I think Claude performed way better than Gemini. Okay, so I think we have a clear winner here. So if you look at round 1, where we asked Claude and Gemini to create an animated image of elephant near a pond, both performed their task well. They created the animation correctly. I gave a point to Gemini because in terms of visualization, it was better. Round 2, hands down, Gemini won. Third round, linear versus binary search. Both models performed really good, but in terms of visualization, in round 3, Claude was better. And the same applies for round 4, where I asked to draw a kind of an animation of feed-forward neural network. Animation of Claude was better as compared to Gemini. And in round 5, Claude was hands down better as compared to Gemini. So we have a winner. I hope you enjoyed this video. See you in the next one. Bye-bye.